Okay, so it is currently looking like 11:40 on Monday morning. It's for my integrated math students. We had a Zoom meeting at 11 o'clock, which none of you attended, which is okay. I know it's new. I know it's different. Hopefully we can get a schedule and make it feel as normal as possible. But I got all dressed up and pretty, put pants on. I'm kidding. I'm not kidding that I put pants on. I already had pants on. Put my bow tie on. Would have gotten to see me in my bow tie. But hopefully you guys can start making those meetings. If you can't, drop me an email, call me, and we'll figure out what to do. So normally what the plan is at those Zoom meetings we'll go over either a review topic or a new topic. And then I will take a video of those meetings and post them to YouTube. And then I'll link the YouTube video into the Google Classroom video. And I'm probably also going to start putting the links for the Zoom meeting into Google Classroom as well. So for this class, the Zoom meetings are going to be every Monday and Wednesday at 11 o'clock. So I do want to go over some stuff with you guys. When we left off, we were talking about trigonometry, sine, cosine, tangent. So I want to do a very brief review of that. So we have three different, what are called trigonometric functions. And that is sine, cosine, and tangent. And how we remember what each one of those are is with the mnemonic SOHCAHTOA. And SOHCAHTOA is how we remember which sides of the triangle form which trigonometric ratios. So, S-O-H, stands for sine is the opposite side over the hypotenuse. See how right there we have S-O-H? Trying to circle something with the eraser. It did not work well. S-O-H. So, then we have CA, C-A-H. And that stands for cosine is the adjacent leg over the hypotenuse. And finally, we have tangent is the opposite leg over the adjacent leg. So you can see that on each of these, the first letter of each one spells out SOHCAHTOA. Now, I know that SOHCAHTOA isn't actually a thing, but again, it's something that you can remember fairly easily, and hopefully remembering SOHCAHTOA would be easier than remembering, something like sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So, what do these mean? Opposite, adjacent, things like that. So here we have a triangle. We're going to call it triangle ABC. And we're going to make it a 3, 4, 5 triangle. Now, when we're talking about opposite and adjacent, it's important that you remember it depends where you're looking from. Okay, so think about Cottonwood. Okay, we all live in Cottonwood or the Verde Valley. Now, if I'm in Phoenix, Cottonwood is north. If I'm in Flagstaff, Cottonwood is south. So depending on where I am and what my point of view is, will determine what is opposite and what is adjacent. For those of you guys who don't remember, adjacent means next to. So we're going to start off by looking at this from A's perspective. Now from A's perspective, that 4 side CB, that is opposite. And the 3, the one right next to it, is adjacent. So that means that the sine of A, which is, again, if we go back to the other page and look, we have SOHCAHTOA. Sine of A is O over H. Opposite over hypotenuse. Oh, so the hypotenuse, forgot to mark the hypotenuse. The hypotenuse is always going to be this one. It does not matter where you're looking at it from. The hypotenuse is the hypotenuse. Think about it like, it's because it's not directional. Opposite and adjacent are directional. Hypotenuse specifically refers to the long side of the triangle. So the sine of A, the opposite over the hypotenuse, is 4 over 5. The cosine of A, which is the adjacent over the hypotenuse, is 3 over 5. And the tangent of A, which is the opposite over the adjacent, is 4 over 3. So these, now what we learned, and if you look back at what I call trigonometry review, which is just right triangle review, these are specific to a given angle, okay? So, like, we know that if it's a 30, 60, 90 triangle, the sides are always going to be in the ratio of 1 to the square root of 3 to 2. So we know that in a 30, 60, 90 triangle, the ratio of the side opposite the 30-degree angle to the hypotenuse is always going to be 1 to 2, or 1/2. If you have a calculator and you put 30 sine, it would tell you it's 0.5. So what if we switch our perspective? What if we go to B? Now B, the opposite is 3, and I put the adjacent as 5, which is wrong, because I'm an idiot. The adjacent is right here. This is the hypotenuse. See, it doesn't matter whether it's blue or green, whether it's from A or B, the hypotenuse is always going to be the 5. So the sine of B, opposite over hypotenuse, is 3 over 5. The cosine, now I forgot to, cosine of B is adjacent over hypotenuse. Tangent of B, okay, so I just wrote tangent of B before I wrote out the cosine of B. Why? I don't know. So the cosine of B is the adjacent over the hypotenuse. The adjacent, the side next to, so when we're talking about, again, the opposite and adjacent, we're talking about these legs right here, okay? So the adjacent leg is 4, and the hypotenuse is 5. Finally, we have the tangent of B being the opposite over the adjacent. So we're in blue now. We're looking from B. Opposite is 3. And the adjacent is 4. Now notice how, when we look at this, the trigonometric ratios of one angle are related to the other. And this, we'll get into this more later, but I want you guys to start seeing this now. So notice that the sine of A is equal to the cosine of B. The cosine of A is equal to the sine of B, and the tangent of both A and B are the inverse of each other. They're flipped upside down. And this should make sense. If I know that A and B are both angles in a right triangle, that means they're supplementary. So let's say that A was 18 degrees. Okay, so if A is 18 degrees, and I know that C is 90 degrees, well, that means B always has to be 76 or 72 degrees. Because 72 plus 18 is 90. So that's why 30, 60, 90 triangles always appear that way. Because if there is a 90 degree angle and a 30 degree angle, We know that triangles always have to add up to 180. So we know that the other one has to be 60 degrees. So we know that whenever there's a right triangle and we have an angle like A there, we always are going to have an angle like B there. Okay, I know that's a little bit out there. But it just shows you that these triangles, all of these triangles, all 30, 60, 90 triangles, all 45, 45, 90 triangles, all 18, 72, 90 triangles are all going to be similar to each other by angle-angle similarity, which hopefully you guys remember from your days in geometry. So if you guys have any questions, what I'll end up doing is going ahead and probably posting an assignment on this either later today or tomorrow. And then I will hopefully see actually some of your faces on Wednesday. So stay safe, stay sane, and I'll talk to you guys later.